Right, so we're now going to look at colour depth in a little bit more detail. This is going to be activity 2 in your journal under lesson 7. So rather than you do what it says in the journal, which you're going to struggle to do with me not being in today, and also some of you might be on your Chromebooks, in which case this won't work. I'm going to model this. I'm going to show you the activity, and then you should be able to answer the questions below. Okay, so we've got here color depth, file size. It tells us to download an image to our PC. I've already downloaded it. Open it in Photoshop. I've already got it open in Photoshop. And then we're going to have a look at what the file size of that image is. So the original image, if I look at it here, is this one here. And the file size, it tells you down here, is 5.93 megabytes. Okay, so it's 5.93 megabytes is the size of this picture. Now you'll notice it's actually zoomed in to just 50% at the minute. If I just zoom to its proper size, that's the actual size there. If I can get it to 100, that's the actual size of that image. So it's decent quality image to start with. Okay, let's just go back so we can see the whole image on the screen. Now you can change the color depth on here. There's various different ways to do it. I'm going to go to image and mode, and I'm going to change it to 16 bits. So remember, 8 bits is a byte. Okay, that allows us to store 255 different colors. So this picture currently is made up of 255 different colors. So there's just different shades of different colors within there. If I change that to 16 bits there, then what happens is it's now made up of a lot more colors, because I can have 16 bits, 16 zeros and ones, as opposed to 8 zeros and ones. So I can make a much larger number than 255. If you want, you could actually work out what that number is by coming up with the largest binary number that you can come up with 16 zeros and ones. So if you went 1111111 all the way through 16 times, and then worked out what that is in denary, that is the amount of colors that we've now got available to make this image. And the bit that you need to take notice of is down here. The file size has increased to 11.9 megabytes because it needs more space to store all of those extra zeros and ones. So the file size has increased. So if we just go back to the journal question, it says here, you've got to fill in this table with what happens if you increase the file size. So I've just increased it there to 16-bit, which is actually this one in the middle. I know it looks different to that. So you can put in there 11.9 megabytes. Remember, the first one was 5.9. Now, if we change it to 32-bit, then it'll take up even more space. So I'm going to go to mode, change it to 32-bit, and you'll notice it doesn't even give us the file size now. We've made this image so big that it's probably going to be quite a large image. Okay, it gives us a little slider instead, and you can change the color depth by actually sliding this little slider along. If I save it, we'll be able to see what that image size is. So I'm just going to click OK to that, and I'll just call that test and click save. And that's in my Chrome downloads. So what I'm now going to do is try and find out what the file size is. Go to file info, and hopefully in here somewhere it's going to tell me the file size. Maybe it's not. There we go. I found it in image size, and it's now 23.7 megabytes. So in your journal, that's what you're going to write in here, 23.7 megabytes. Okay, so if you've done this activity yourself, you've got those same answers. But as you can see, it's a bit complicated without me there to explain it to you and help you. So it's 5.9, 11.9, and then whatever the last one I said was, 23.7. Okay. Now, the reason that happens, like I say, is because when you increase the number of bits, you have more colors to choose from. So you can see here with these images that are on screen at the moment, just make that a bit bigger for you. This one, the 32-bit image, is far, far more detailed than the 1-bit image, which only has 2 colors to choose from. Okay, that might look like there's more colors there, but it's actually not. It's just the dots are spaced further apart to make it look darker and such like. Now, this applies to computer games as well. You can see on here, there's a game at the left, Commando, which had 8-bit graphics. We've got 16-bit graphics in the middle. We've got 32-bit graphics at the right-hand side. You can make far more realistic scenery using 32-bit graphics because you've got more colors to choose from. I actually quite like Commando, and I quite like the 8-bit graphics there. But like I say, if you want to make really good graphics, you need a higher color depth. So that should help you answer this question here. What happened to the image size as number of colors, color depth was increased, and try to explain why. So if you'd like to pause the video now, you can have a go at that, and I'll move on when you come back. Okay, so you've had a go at that hopefully, and you've filled in that part of the journal, activity 2. We're now up to activity 3, which is where we're actually going to look at how a computer really stores this information. Now, you can visualize this using a spreadsheet. There's quite a clever link that allows you to do that. So when you click on this link here, which is in your journal under activity 3, it allows you to open up an image. So you can use the one that's under activity 2 if you want to download that image, and then you can upload it again to this website. Now, once you've chosen your photo and put it up there, you then download it as an Excel spreadsheet. I'm going to show you how to do this, and then you can see what that looks like. And then you just have to take a screenshot and put the image in here to show that you've done that. So let me show you what I mean. We're going to go to this website, and if we click on choose file, we're going to upload an image. So I'm just going to find that one, which I think was called Splash something or other. Here we are, splash of colors. So I'm going to open that up and then click this button to convert it to a spreadsheet. You're going to do this in a moment. So I've clicked convert to spreadsheet, and it's currently doing that. You can see I've actually already done this below. I've got 2 of them now. I'm going to open up that spreadsheet. You can do this in Google Sheets as well as Excel. It might come up with a little error message. Just click yes, and then enable editing, and close any little things that come up. So at the minute, this just looks quite dark, okay? So this is actually that image with all of those different red, green, and blue colors mapped out. This is how a computer actually stores this image. Now, if I zoom out a bit, so down here I've got it's on 100% currently. If I just change that there, so it's smaller, you can actually see how that makes up that image. So all of those different squares have been used with different colors in to produce that image. When you combine them together, it creates the image that picture is, okay? So all you would do is you open that up, zoom out to a point where you can see it, take a screenshot, and then pop that into your journal to show that you've done it. And hopefully you understand a little bit now. If I can just find the journal again. Sorry, I'll go back to the slides, that'll be easier. So it's going in there under activity 3 in that box. So hopefully you understand a little bit now about how computers store images. So red, green, blue colors, the more bits, the more variations of those color you can actually have. And it can then obviously convert into binary, which is how it stores it on your computer. So that's the end of this lesson. If you do have any extra time, by all means go back to the binary game and do some practice trying to convert from binary to denary and denary to binary. And thank you for watching the videos.